All right. Take 20 from the 403 to the HAZ. Mr. Nelson here. I've tried making this video about 5 times now. Something goes wrong every time after I've spent about 10-20 minutes teaching it. So let's try it again here. I doubt it's going to work. I'm looking for my markers that I literally just had in my hand. Where did I put them? There it is. Okay, great. Hi, Pre-Cal 12. Hi, guys. Hi, I'm present. Hello. We're starting trigonometry. We like trigonometry. Well, we liked it in grade 10. Grade 11, it got a little weird. I think grade 12, it gets cool again. It's chill. But what we need to do is we first need to remember what we learned in grade 11 pre-cal around trigonometry, specifically around the unit circle. Okay, we were working with the unit circle in pre-cal 11. And the unit circle is exactly that. It's a circle with a radius of a unit of 1. And it's kind of what we base everything on, or extrapolate everything from. So here's our unit circle. Very symmetrical. Let's just pretend. Let's just I just gotta stop with that. Better, who cares? Okay. So, and we recall from pre-cal 12, this is our starting point. This is our starting arm. We start all of our counting of angles from here. Okay? And our angles in blue, we start at 0 here, 0 degrees. We get 90 degrees up here, 180 degrees, 270, and a full rotation is 360 degrees. When we're calculating or when we're determining angles in standard position, we move counterclockwise, if you remember. If we move clockwise, then this will be my 0. Sorry, that's going to be my 0 anyways. My 0 will be here as well. Then this will be negative 90 degrees, negative 180, negative 270 degrees, and negative 360. If I keep going counterclockwise, once I hit 360, I just keep counting. So 2 rotations will be 720. Conversely, if I go clockwise, 2 rotations will be negative 720 degrees. Okay. My reference angle, if I recall, so my terminal arm is going to be any arm that basically makes an angle. Okay, so if I'm over here, that's my terminal arm. This angle, starting from my starting position, going counterclockwise to my terminal arm, this is my angle in standard position, theta. Okay? And my reference angle, with reference to that terminal arm, is always going to be the angle that's made between the terminal arm and the closest x-axis. Okay? So if my terminal arm is here, this would be my closest x-axis. That would be my reference angle. If it was down here, okay? And then my co-terminal angles are essentially 2 things. It's either the angle that is made when I go the opposite direction, so clockwise. So the angle that is made with that terminal arm, this is going to be a coterminal angle. We're going to call it theta co. If I keep going and do another rotation, that'll be another coterminal angle. Conversely, if I start here and do another full rotation, I would say this was 150. If I add another 360, that'll be another coterminal angle, okay? That is basically a quick review of what we learned around circle trigonometry, the basics. Now, and let's also remember we have quadrants, quadrant 1, quadrant 2, quadrant 3, quadrant 4, and let's make sure I'm still filming, because gee whiz, I have just had terrible luck. I'm actually still filming, great. Okay, so as we move forward in grade 12, in grade 11 we were working, in 10, 11, we're working with degrees, because degrees, you know, it's easy to understand. I don't even know if that's true, because radians make sense too. So we're going to start working with a new unit of measurement around angles called radians. And if you've played around with your graphing calculator, you've probably noticed that you can switch between radians and degrees as much as you want. Okay, so the first thing we need to do is learn how to convert between radians and degrees. And it's quite straightforward. Here's the relationship. 1 degree is the same as pi over 180 degrees. Okay, that's the first relationship. And 1 radian is the same as 180 degrees divided by pi. Okay, these are my special salsa. This is my special salsa. Mama special salsa, okay? So, let's now use this relationship, because I know that 1 degree is equal to pi over 180. Let's use this relationship to figure out what 90 degrees would be, 180, 270, and 360. Okay? So if I use that, if I know that 1 degree is equal to this, then 90 degrees, where should I do it? Let's do it right here. I'm going to do each one. So 90 degrees is equal to 90 of these. So 90 times 1 pi over 180 degrees. Now my degree units will cancel out, leaving me with just no units, which is radians. And I get 90 pi over 180. And then if I simplify this fraction by dividing the numerator and denominator by 90, I get pi over 2. So 90 degrees is the same as pi over 2 radians. Okay, let's do 180. 180 degrees means I have 180 of these. So 180 degrees times pi over 180 degrees. My degree units cancel out, and I get 180 pi over 180. The 180s cancel, leaving me just with pi. So 180 degrees is the same as pi radians. And 270 degrees is the same as 270 times pi over 180. And I get 270 pi, the degrees cancel out, over 180. If I simplify this fraction, I get 3 pi over 2. So 270 degrees is the same as 3 pi over 2. And then if I went to 360 times pi over 180 gives me 2 pi. So a full rotation, 360 degrees, is the same as 2 pi radians. Okay, so that's how we use the math to convert from degrees to radians. Now, radians, at least in high school, we like to work with radians that have pi. Pi is a component of radians. It's an important part. Sometimes we just leave it in this format, pi over 2, right, when it's nice and clean. Other times we'll actually convert that right to a number. So sometimes we might say, okay, here's an angle, and we have an angle of 2.25 radians. If there's no degree here, we're going to assume we're in radians. So if I have this radians, and I want to figure out how many degrees it is, well, I'm going to use this relationship. So I have 2.25 of these, so I'm going to multiply that by 180 degrees over pi. And when I do that, 2.25 times 180 divided by pi, 2.25 times 180 divided by pi, I get approximately 131 degrees, okay? And so that's if they just gave me a number. If, say for example, they gave me pi over 6 radians, okay? So if they gave me pi over 6 radians, and I wanted to turn that into degrees, I'm going to do the same thing. Pi over 6 times 180 over pi. And then my pi's will cancel, and I just get 180 divided by 6, 30 degrees. So whenever there's a pi in my radian measurement, usually it's going to let me work out to a nice clean degree. When it's in this form, typically it's going to be something else. So that's converting between radians and degrees. It's just this, okay? And so the final thing we need to learn how to do to be able to attack our practice problems is calculating arc length. And to do that, I'm just going to draw a circle. So say they give me something like this. Okay, this is part of a bigger circle, but this is my slice. Okay, and they tell me that this angle is 1.22 radians, and this is my arc length here. Okay, and this is my radius, 9 feet. So this is the other type of problem we're going to see in our practice problems. Now, this is just a fraction of a whole circle, right? And we're going to basically use ratios to calculate our unknowns here. Now, if I had a whole circle, my circumference, my entire arc length around that circle is c, or is equal to 2 pi times r. Okay? And my entire, if I'm working in radians, an entire rotation is, it's 360 degrees or pi. So an entire rotation is equal to 2 pi. So we're going to use ratios of my angle as opposed to as a function of my full circle, and we're going to relate that to my arc length as a relation to my full arc length, because it's the ratios work. So basically it looks like this. We're going to have my arc length over the entire circumference is equal to my angle over an entire circle angle, which is 2 pi. This is how I'm going to solve arc length problems. And I am just going to solve for my unknowns. So in this case, my unknown is A, and I know that my angle is 1.22 radians. Now it has to be in radians because I'm working with 2 pi here, which is a radian measurement. So to solve for A, I'm going to multiply both sides by 2 pi r to get rid of the denominator there. And I get 2 pi r times my angle theta divided by 2 pi. 2 pi and 2 pi cancel, and I get my arc length is equal to my radius times my angle, or 9 feet times 1.22. And I get an arc length of 9 times 1.22, 10.98 feet. Okay? There we go. Now let's say that they didn't give me the angle and I have to solve for the angle. So here's another problem. Okay, I'm going to draw a new arc. It's going to be something like, it'll look like this. Okay, so here's my new arc based on this slice of my circle. I don't know my angle theta. I know that my arc length here is 9 centimeters. And I know that my radius is 4 centimeters. So I'm trying to calculate this angle. And I'm going to use this formula here. I'll leave that there. I'm going to do it right here. It's easy. So I'm just going to write out my ratio. My arc length over 2 pi r, which is my circumference. So my cut of my entire circumference is the same ratio as my angle as a function of the total angle. And I'm now solving for theta. So I'm going to multiply both sides by 2 pi to isolate for theta. And I'm going to do theta is equal to 2 pi times a, 2 pi times a, divided by 2 pi r. And my angle, therefore, is equal to a over r, which is Arc length, 9 centimeters over radius, which is 4 centimeters. And this gives me an angle of 9 divided by 4, 2.25 radians. Okay? Now if I wanted to convert that into a degrees, all I would have to do is multiply 2.25 times 180 over pi. So 1 rad is equal to 180 degrees divided by pi. So 2.25 rads is equal to, and we did that one before, 2.25 times 180 degrees over pi. And that gives me some 130. 2.25 times 180 over pi, 128.9. Okay. That's enough to get us going. Practice the problems and we'll keep moving forward. Please, please, the film, please. Yes.